Hi, in this video I will do another example for the first derivative test. The nature of the example is a little bit different, in which the function f itself we don't have, but we have been given the derivative of the function. It's this function. Then the question asks for the critical points of f and determine which one of these give you local max or local mean, relative max or mean for the function. Okay, so we will start with recalling that critical points are the points either at which either f prime is not defined, in other words, f is not differentiable, or f prime is defined and is equal to 0. In this case, you see that f prime is defined everywhere. So we need to just check what are the points which makes f prime 0. So in this case, x squared minus 4, x squared plus 6x plus 9 is equal to 0. Well, let's just do a little bit more work here. So it will be x times x minus 2 x plus 2. This is x plus 2 minus x minus 2. And this one here is nothing but x plus 3 squared. And if this is equal to 0, we have 3 or 4 points, which either x is equal to 0, x minus 2 is equal to 0, x plus 2 is equal to 0, or x plus 3 is equal to 0. And that is x0. From these guys, what we get is that x0, 2, negative 2, and negative 3 are the critical points. So these are the critical points. But when you have critical points, you can use the first derivative test, the first derivative test, to determine what kind of points are those ones. For that, we need to write down the table of f prime, the sign table. Oops. And here we have negative infinity. I have negative 3 here, negative 2, 0, 2, plus. And at those points, f prime is 0. And now we want to have some what kind of points, the sample point, or here I can choose negative 4, I can choose negative 2.5 or negative 5 over 2. Here I can put negative 1, 1, and then 3, and that's it. Okay, well, we have to evaluate f prime at the given test value. So at negative 4, for example, I will use this version of f prime. So it will be negative 4 times negative 4 minus 2 times negative 4 plus 2, and then negative 4 plus 3 squared. This is negative 4 times negative 6 times -2 times -1 squared. You see that this will be positive. This is negative, negative, negative. 3 negative sign, that will give me negative numbers. So f prime at this interval is negative. How about at this other interval? So we have to evaluate this as -5/2. This is -5/2 times -5/2 minus 2, -5/2 plus 2, and then -5/2 plus 3 squared. I don't need exactly to evaluate this value, this function at this point. I need only the sign. So this piece here, whatever is inside, square it, you get positive number. Here, this is -2.5 plus 1. This is a negative. This is another negative. This is another negative. 3 negatives, you multiply, you get a negative sign. So this interval is going to be negative also. How about f prime at -1? F prime at -1 is -1 times -1 minus 2 minus 1 plus 2 minus 1 plus 3 squared. Again, let's go this one. This number, whatever it is, square of that's going to be positive. This is 1, this is positive, this is negative, this is negative. There are 2 negative signs, so you multiply, you get positive. And for 1, f prime at 1, this will give me 1, 1 minus 2, 1 plus 2, 1 plus 3 squared. This is positive, this is positive, this is negative, this is positive. The whole thing is going to be negative. And the last value, if you plug in, you will notice that is plus. So when you do that, now it is the time to use the first derivative test itself. For that, what you can see is that while f prime negative f is going to be decreasing, then decreasing, then increasing, decreasing, and increasing. Here, now we have to use the test one by one. At -3, the sign of f prime before -3 and after -3 stay the same. So this is neither relative max nor relative mean. But this one is first decreasing, then increasing. So this is relative mean. This is increasing, then decreasing, relative max. And this is increasing, then decreasing. This is relative mean. So then we can write that f has a relative mean at these points, x equal to -2 and 2, and f has relative max at just x equal to 0.